We are going to start solving more trig equations. And this lesson is going to get a little more exciting. Okay, we're going to solve this equation in the interval. That means we're going to need some charts. But look at the name of that angle right there. Okay, so right here, the name of the angle is getting a little more exciting. That's not going to change a whole lot of our work, same process, so there's no solving that we need to do here. You can't divide by 2. Okay, so we're ready to start with a little mini unit circle. Where is the sign positive 1/2? Sign is 1/2 at pi over 6, and he's positive in quadrant 2 at 5 pi over 6. Usually stays in the same family, right? Can I write those two places as one equation or two equations? Okay, we're going to need two equations. So the first answer is pi over 6. Okay, but the name of the angle is 2 pi. So what you say is the angle 2 theta is pi over 6. The first place is pi over 6 plus or minus 2 pi n. And here's another answer. So what angle do we have? We have 2 theta right there at 5 pi over 6. And we'll travel around a full circle until we get back to him. Okay? So the new thing here is the name of the angle. Now, 2 theta equals that. But I have to solve for theta. So here's the new thing. We're going to divide by 2, but each and every one of them has to get divided by 2. When you divide by 2, is the 2 going to go in the numerator? No, that would be like timesing by 2. The 2 is going to go in the denominator. See how it got divided by 2? They go in the denominators. Oh, same thing here. We're going to have to divide by 2, and dividing by 2 puts a 2 in the denominator, not in the numerator. Right? Isn't dividing by 2 the same as multiplying by 1/2? The 2's got to go in the denominator. So theta equals pi over 12 plus or minus pi n. And theta equals 5 pi over 12 plus or minus pi n. The directions here said in the interval, so that means they want us to make some charts. So let's go ahead and put this first equation in a chart, and the second equation as well. And what I'm going to do to make things easy here is write pi as 12 over 12. Let's do that here. Make some common denominators. So when we're going down our chart, let n equal 0. The first one is pi over 12. We need to add 12 every time. All right, so when n equals 1, what's 1 out of 12 plus 12 more? 13 pi out of 12. Is that too much? No, that's not too much. Hey, how much out of 12 is too much? The answer is 24. All right, so let's keep going. Let's add 12 more to that. 13 plus 12 is 25 pi out of 12. Is that too much? Yes, that is too much. So let's go ahead and cross that one out. All right, over here, when n equals 0, you get the first angle, 5 out of 12. Let's go again and add 12 to that 5, and that's 17 out of 12. Out of 12, 24 would be too much, so that's okay. Can I fit 12 more? Nope, can't fit 12 more. So let's write the answers in a set. And taking a look at these, let's go small to big. The first one is 1 out of 12. Then comes 5 pi out of 12. Then 13 pi over 12. And 17 pi over 12. Perfect. That's the set of answers from 0 to 2 pi. Yeah, that's good. Here's a hint. Okay, we must get the trig equation function alone, the trig function, but we cannot alter the trig angle. So notice how we started with the angle of 2 theta. That's just what we solved with. You can't divide by 2 because that's not out in front. The trig equation, sine of, was alone. Okay, so here's one. The trig equation is sine of, I can't alter the angle, but I can get that 1 out of there. I can get the trig function alone. So this is sine of 3 theta equals 1. Okay, you cannot divide by 3. The angle has to stay the way it is. All right, let's see. This says solve in the interval. That means we're going to have to use a chart. I can't do any more algebra, so let's go to our unit circle. Where is sine positive 1? Up here at pi over 2. Yeah, and where else? Where else? Nowhere else. You're correct. Okay, so we're going to make an equation. The name of the angle is 3 theta. And did we figure out where the angle is? Yes, pi over 2. And how much are we going to add to get to another answer? A full circle, plus or minus 2 pi n. Okay, if it said solve in general, I would still have to do the next step, divide by 3. But I have to make a chart, so let's divide by 3 here. We're going to divide him by 3. Everyone gets divided by 3. The 3 is going to go in the denominator. All right, so the angle is theta equals pi over 6 plus or minus 2 pi over 3n. All right, we need to make a chart so we can find our table of angles. So let's go ahead and put this here. Maybe we should make common denominators so this is easier for us. So let's change 2 over 3 into 4 over 6. Okay, so every time you go down the chart, you need to add 4, add 4, add 4. Here we go. When n is 0, the first one is 1 pi out of 6. When n is 1, let's add 4 more to that. That's 5 pi out of 6. Can we keep going? All right. The next one, when n is 2, add 4 more to that. That's 9 pi out of 6. Let's add 4 more to that. 13 pi out of 6. How much out of 6 is too much? Well, 12 would be too much. Okay, so this one's too big. Okay, in fact, this one right here, this one needs to get reduced to 3 pi over 2. Okay, so let's not forget that we must reduce the angles. It's nice to see 9 pi out of 6. That way when I'm putting them in order, I know where it goes, but I need to call it 3 pi out of 2. So our solution set is 1 pi out of 6, 5 pi out of 6, and 3 pi over 2, because I know that's the order it goes in. So starting today, when the angle is a little fancier, your solution set is not going to match your unit circle directly because we had to divide by 3. Okay, so that's the different part. When you have fancy angles, the charts are going to get a little more exciting today. All right. What else do we have? Solve the equation in general. So now that it's in general, that means all we have to do is make the equation. Make the equation and we get to stop. Okay, do we need to do any algebra? Yes, this is not the function alone, so let's divide both sides by a 2. By a 2. Does the angle get divided by 2? No. Let's put some parentheses so we don't alter him. So cosine of 3x equals radical 2 over 2. All right, there's no more algebra. The angle and the function are alone, so let's go to a unit circle. Where is the cosine radical 2 over 2? At pi over 4. Where else is it positive? 7 pi over 4. Okay, so let's go ahead and say 3x equals, the first angle is pi over 4. Pi over 4 plus or minus 2 pi n. And then let's do this angle over here. The name of the angle is 3x, and the angle that we found, the answer is 7 pi over 4 plus or minus 2 pi n. Now we have to divide them. Let's divide each and every term by 3, 3, 3. Divide him by 3, 3, and 3. Okay, so x equals pi over 12 plus or minus 2 pi over 3n. And then the other answer is 7 pi over 12 plus or minus 2 pi over 3n. Now, some of you might have been wondering, can we, since it said an equation in general, and I don't need to make charts, could I have written these two equations together? And yes, you can. So let's show people what that answer would have looked like. 3x equals, either you go up or you go down, and you get yourself to an answer. So plus or minus pi over 4. After you choose go up or go down and you're at an angle, then you travel a full circle, 2 pi n, to get back to that answer. So when you have this kind of an equation and you divide them all by 3, x equals plus or minus pi over 12 plus or minus 2 pi over 3n. So you can have two equations written together as one, and that's how you say it in general. Now, we don't want to ever make charts with something like this because you'd have to have let n equal 0, a positive 12, a negative 12. Then you'd have to say plus 2 pi over 3n and then minus 2 pi over 3. What's negative pi over 12 plus 2 pi over? And you have to do the negatives plus, the negatives minus. It's just way too hard to do the chart that way. So doing two charts guarantee you have all the answers. Okay, the next one says solve in the interval. That means we're going to have to make a chart. Okay, let's see. Is this equation ready, or is there algebra I must do? Okay, we can't alter the angle, but you can square root both sides. Square root both sides. The angle doesn't get affected. It's just the function tangent of 5 theta over 4 equals, what's radical 1? Oh, good. Plus or minus 1. Don't forget. Okay, let's go ahead and make a unit circle. Oh, I love tangents of plus minus 1. Where is tangent 1 or negative 1? Pi over 4. 3 over 4. All of the pi over 4s, right? How many equations are you going to make? Yes, just one equation. Okay, what's the name of the angle? The name of the angle is 5 theta over 4 equals, okay, the first angle here is pi over 4 plus or minus the space to the next one, pi over 2n. You don't want to say plus or minus if you don't have to. Since I can start with the first positive one and travel around, don't put plus minus here unless you're making just an equation in general. The chart's too hard with negative plus and negative minus and positive plus. Okay, let's get to theta. So what I'm going to do here is use the reciprocal. I'm going to multiply by 4/5 to get to theta. I'm going to have to multiply each and every term here by 4/5. So theta equals, let's cancel 4 and 4, pi over 5 plus or minus, let's cancel a 2 and a 2. That's 2 pi over 5n. That would be the answer if it said in general, but they want a table of values. So let's go ahead and make our chart. When n equals 0, we get pi over 5. Ooh, common denominators are built in. Awesome. When n is 1, add 2 more to that. That's 3 out of 5. When n is 2, that's 5 out of 5? Pi. Can we keep going? Yes, that's not 2 pi. I'll just keep making my chart through this problem. When n equals 3, 5 out of 5 plus 2 more is 7 out of 5. How much out of 5 is too much? 10. Oh, let's keep going then. 7 plus 2 more is 9 out of 5. I think we've reached our maximum. We can't add any more. So our solution set is 1 out of 5, 3 pi over 5, pi for 5 out of 5, 7 pi over 5, and 9 pi over 5. Solution set. So the tables get a lot more fun when the thetas are different and your answers don't match your unit circles anymore. But it's the same process. Okay, solve the equation in general. Oh, good, no more tables. Okay, let's do some baby algebra here. First, you move the radical 3 to the other side, and that makes negative radical 3. Now we'll divide both sides by 2. When you divide by 2, the coefficient cancels. Does that alter the angle, though? No, the angle stays the same. So negative radical 3 over 2. That seems familiar. Cosine being negative. That happens in quadrant 2 and quadrant 3. Where? What family is that? 5 pi over 6 and 7 pi over 6. Okay, so the name of the angle is 2 theta. Should we try writing this as one equation? Since it says general, I don't have to make a chart, so I know that I can put them together. If I go up this much or down this much, how much is that? That's plus or minus 5 pi over 6. After you decide to go up or down and you're at an answer, then you're going to swing around plus or minus 2 pi n. Okay, we would never do this if you had to make a chart, but I can combine this into one equation and the work will get a lot smaller and faster. Let's divide each of them by 2, by 2. Put a 2 in the denominator there. So theta equals plus or minus 5 pi over 12 plus or minus pi n. Okay. Thanks for your attention.